Greetings everyone. We're going to do a tutorial on repeated measures ANOVA and the dependent t-test using JASP. So I'm going to share my screen here with you all. And here is a JASP data set. This is what's known as the employee data set that I've been using. It shows a beginning salary and an ending salary. And we'll see if there's a statistically significant difference between a beginning and ending salary. So from here, I'm going to go to ANOVA, and I'm going to choose on repeated measures ANOVA. And I'm going to choose a factor here, something like maybe time, between beginning salary or ending salary. So I'll just call this time. And, for level 1, I'll put in beginning salary. I might have to name it beginning salary. And level 2, I'll call current salary. And so you can see now that it's putting these levels here, and then I just move the variables to their respective location. And JASP is already running the F-test. But before I look at that, I do want to note a couple things here. I want to run a sphericity test, and that's the most important thing. And when you have 2 and only 2 levels, you don't usually have to worry about, you don't have to worry about sphericity. This is perfect. There's no concern here. So, but if there was a problem with 3 or more levels, I might need sphericity corrections. And now I can also put on descriptive statistics, estimates of effect size, and we're ready to look at our results. So here, F of 1,473 equals 1,227.52, an eta squared of 0.30, accounting for 30% of the variance in the model. That's a lot. I don't need to worry about between subjects effects. I don't have a between subjects effect here. And then here are the descriptive statistics. Notice how much the salary increased from 17,016 to 34,419. So that, quite a substantial increase. But we also see very large difference in standard deviations. There's a lot more variability in current salary than there was in beginning salary. And then if I want to evaluate what this would look like as a dependent t-test, I could just click on post hoc, move time over, and I don't need a correction here, so I can eliminate that. And I can click on effect size, and notice here it gives me a t-test value saying that that the beginning salary was 35. That the beginning salary was lower than the current salary. The t-value is 35.036. The Cohen's d is 1.61 standard deviation units. So the change, we saw that an eta squared was 30% of the variance accounted for, expressed in standard deviation units. This is over 1.5 standard deviation unit difference. Notice that if I take the t-value of 35.036 and I square that value, I get 1,227.52, the same value that's right here. T squared equals F, And you say, well, what couldn't I just run this as a dependent t-test? Sure, you could have. You could have just gone to appeared samples t-test, put in your 2 variables here, and ask for your descriptive statistics and your effect size, and you would get the exact same results between the t-value of 35.036, same p-value, same degrees of freedom, same Cohen's d, so nothing changes here. So that's how we look at a repeated measures ANOVA or a dependent t-test.